Good morning, everyone. Welcome to today's webinar hosted by our Solutions Engineering team. My name is Amanda McLeod, and I'm going to introduce you to our speaker today. Today, we will discuss how to leverage Vault to quickly and securely generate PKI and SSH certificates. I'd like to introduce you to our presenter today. Jake is a Senior Solutions Engineer at HashiCorp. Jake is going to introduce HashiCorp Vault along with the new open source GUI. Jake will do a live demo showing how to create PKI certificates, SSH certificates, and signing public and host keys. Next, Jake will wrap up by answering any questions you all have. I also want to note this webinar is recorded, and the recording will be made available after post-processing, usually within about a day or two. I'll email it out to all of you. With that, let's go ahead and get started, Jake, and I'm going to hand it over to you to get your slides up. And
okay. Let's see. Okay, good. There we go. Everything looks good. All right, outstanding. Hi, everybody. Good morning. I'm Jake Lundberg, Senior Solutions Engineer for HashiCorp. If you happen to have joined the wrong webinar, we're going to be talking about streamlining certificate management with HashiCorp Vault. If you joined the wrong webinar, that's fine. Stay a while and listen. I'll make it worth your while. Okay, so first of all, I'm going to give you a warning. This is an interactive presentation, so I may ask you to raise your hands or put some answers inside of our questions or inside of our chat. Please feel free to do so. Those who answer trivia questions firstly and accurately will win a prize of my choosing, and we'll use your registered email to contact you should you win a prize. We're going to go through a brief introduction, talk about the PKI secrets engine, the SSH secrets engine, and then we're going to demo the PKI and the SSH CA. So a little bit about me. I'm Jake Lundberg. I live in sunny Redondo Beach, California, where I love to take long walks on the beach with my family. That's my wife and my daughter there, walking off into the sunset. I'm originally from Michigan, go blue, but like most Michigan fans, I didn't actually go to Michigan. I went to the U.S. Air Force Academy. I wanted to be a fighter pilot, and while I was there, I learned a little bit about networking. So pop quiz. Oops, I lost my controls. If anybody knows what plane this is, pop that into our questions area. And for an extra super bonus points, if you happen to know what the tail sign is for this airplane, put that in there as well. Okay, I wanted to become a fighter pilot, but I didn't end up doing so because I was very much in love with what was going on at the internet at the time. My first job as a casual status lieutenant was as a Solaris administrator at USAFA, and I spent the rest of my time in the Air Force being a communications officer. Here's some of the flavors of Unix and Linux that I worked on, and most recently in my career I've been very DevOps focused. Before I came to HashiCorp, I was in DevOps for an advertising company. I love playing odd instruments. I've been playing didgeridoo for about 16 years now. I've been playing handpan, that thing that's up on the upper left there, for 5 years, and percussion very badly for 20 plus years. To get exercise, I ride my trusty steed Scott, and I'm a huge gamer. I love Nintendo games. I've been a huge Nintendo gamer since the original NES. Lately, I play a lot of Mario Kart and Splatoon 2, so if you see me online, that's great. I love craft beer. I brewed for a little while, but realized that time and money are better spent drinking quality beer than drinking crafty beer. And just like this guy's t-shirt says, it's not alcoholism, it's a hobby. It's true. I'm a giant Star Wars fan. I saw the originals, all the originals in the theater. I saw Empire Strikes Back and Return of the Jedi on opening day. May the 4th be with us today. All right, outstanding. So, quick show of hands. How many people are actually using Vault today? A second out there. Okay, great. So a quick introduction to what Vault is. When most people think of Vault, they think of it in the context of the center bullet right here, which is a secure way of storing secrets and storing static and dynamic secrets. However, the identity port on the left-hand side is extremely important. Allows us to access those secrets in a variety of configurable vectors, includes rich audit logging, and policy governance. Lastly, encryption as a service allows you to use Vault to encrypt data in transit or at rest without the need of external libraries. Okay, today we're going to be focused on one aspect of Vault, and that's the PKI secrets engine, aka the X509 certificate management for lazy people. And that's fine, I will not tell your boss. X509 certificates are used pretty much everywhere for securing communication between machines. The following process is more likely to support internal mutual TLS setups for application-to-application communication. However, you could use it for web server certificates. Self-signed certificates are often not trusted by browsers, so you definitely get errors, and you'll actually see that in my demonstration, unless, of course, those CA chains are installed inside of your browser, inside of your system. So keep that in mind as we're going through this webinar. So what does the secrets engine do? It streamlines distributing TLS certificates, and you can create PKI certificates with one command. Short-lived TTLs help to reduce any kind of blast damage that you might have from leaked certificates. And CRLs are able to be published and updated, but one of the patterns we find is most useful is to actually just use short TTL, so you don't have to worry about your CRLs or OSCSPs. And if you have existing TLS CSR patterns, Vault is flexible enough to accommodate those workflows. The traditional PKI process usually goes something like this. You create a certificate signing request, and that involves generating your public and private key locally on your machine or some external machine. You sign the CSR with your private key and then submit that to a certificate authority. Typically, the CA signs the CSR and then returns your signed public key, and that's what your certificate actually is. So if you need to do any kind of revocation, you'll update your certificate revocation list or the online certificate status protocol. The Vault PKI process is a little bit different. You just request a certificate. It's a one API call, and you get your certificate back. You might dance or high five from the simplicity, or you might woo woo if that's your jam. So what's the fine print behind all of this? Am I misleading you in this oversimplified process? Possibly. Your security teams or your policies may require that your CA exist outside of Vault. And some reasons for that could be that you have an actual root signing certificate from a real CA. That's not common, but some people have those things depending on the size of your organization. You may have an existing internal CA that your security folks want to maintain. And your CA may be air-gapped, which is what the actual certificate authorities do. They keep those things air-gapped so that they can't be broken into. In Vault, you could actually create your CSR for the intermediates if you have a situation like this. You'd sign those CIs with your existing CA outside of Vault, and then import the intermediate certificates back into Vault. And then you go back to the easy step of just issuing the leaf certs like it is. What we typically recommend, however, is that you actually let Vault manage this entire lifecycle, again, depending on your security needs. And this actually streamlines the entire process because you can use Vault as a full CA. You create the CA, and if you need the private key, make sure that you actually capture it at the time when you create this. And then you create your intermediate or intermediates. You create some roles, we'll discuss that a little bit further, and then you allow the end users or the applications to create their own certificates on demand. An example of a way of separating these out into different certificate domains is that you can actually mount the PKI secret engine into several different intermediates. And so where you may find this useful is if you have many applications that are running inside of the same data center or maybe possibly on the same network that need to communicate with each other, but or don't need to communicate with each other, sorry. If you have these things that need to be isolated from each other, you can sign them with different intermediate chains, and then the PKI certificates won't be able to talk to each other across those boundaries. Okay, let's talk about the SSH secret engines now. For those of you who are systems administrators, you've probably done any kind of SSH logins or telnet logins back in the day. There's a couple different ways you can log into systems. So host-based login is really just allowing your system, any targeted systems, to log in just because of the fact that they have IP addresses. This is clearly insecure sort of a method, because if you have any kind of compromised host, then somebody could actually get across your network. And that's typically bad news. Username and passwords allow for attackers to do brute force attacks against your systems much more easily, and leaked passwords are often hard to recover. So it's a slightly less secure type of a method. Sometimes if you've logged this into, say, an LDAP or Kerberos servers, they can help with that. But what most people tend to use these days is SSH keys. So you typically have to distribute those SSH keys out to the servers before somebody can connect to them. And this can be quite cumbersome depending on the type of configuration management platform that you're using, or if you're using a pattern like SSSD with LDAP-based certificates, you can pull those down from there. But again, it becomes an administration burden making sure that those keys are actually distributed properly. Another thing that's very difficult about this is that it's actually hard to break glass in the event that somebody has a compromised key. And so there's a kind of an interesting way around this, and that's to use a certificate authority to sign SSH keys. And Vault has the capability of doing this. This is a scalable method that it's supported by OpenSSH. It's used extensively by Facebook and Uber. I highly encourage you to go out and check their blog post about this subject. They're very informative. Key signing is not required for every single connection, which is actually very nice. Once you're signed by a allowed CA, you're allowed to get access to those systems. And credentials expire automatically. We'll show these with a small expiration time, but you can get them to use very, very short-lived TTLs down to a minute or less, actually, if you wanted to, though that's not necessarily helpful. Vault also has a way of doing one-time style passwords, and I encourage you to check the documentation on that as well. It allows for very rich user auditing, and of course, it helps to protect against span-in-the-middle attacks, and we'll talk a little bit about a way to prevent that as well. So the actual setup for the Vault side of things is you create an SSH secret mount point, you create the CA cert for that SSH, and then you create roles. Roles are used to create the capabilities a signed certificate has and controls things like time to live, the XSH extensions like permit PTOI, which actually allow you to get a terminal session on the agent or on the system that you're logged into, agent forwarding if you want to allow that kind of thing, and then you can specify the allowed users and the CIDR blocks for which you can connect from. So sort of like the original host-based pattern, you can combine some of these patterns to allow very granular access to systems based off from the way that your certificate is signed. Policies are used to grant access to role endpoints or other endpoints like token renewal or GUI access. And then policies are assigned to authentication methods like LDAP logins, app role for machines if you're doing machine-based logins, or basic token access, which we'll actually be showing today. Distributing CA certs is usually a one-time event, but using tools like Console Template, it's trivial to automate distribution. You also have to make sure that your SSHD is configured to read the trusted CA certs. Again, we'll go over this a little bit during the demonstration. So SSH CA usage is fairly simple. You create the SSH key on your end as a client. You authenticate that SSH client with Vault, and you use a user machine uses any kind of authentication methods attached to the role, like we discussed before, that is allowed to actually sign these keys. And we'll be using the basic token authentication method again. Once that's done, you request your SSH key as a payload is sent to Vault. And then if not done already, the SSH agent needs to be aware that it should use a certificate as a way of connecting. And as a heads up, you will need to combine the certificate and the private key to log in. SSHCA host signing. This is the thing, if you've ever used SSH, you've probably seen some kind of a message like this: authenticity of hosts, tk421.lifestar.com can't be established. And usually what everybody does when this happens is they just click yes, and they just trust that the machine that they were connecting to is the right machine. However, that is subject to man-in-the-middle attacks. Somebody who is quite sophisticated could actually hijack your connection, and you could be connected to the wrong server altogether and be sending information, sensitive information possibly, to these particular endpoints. It is a potential security issue. I don't know that I've ever been subject to a man-in-the-middle attack, but it's hard to say if you just blindly accept these host signings. So there is a way around this by doing SSH host signing. You do the same thing as what you do for the SSH key signing piece of it, is that you create a mount point, you create the CA cert, you create the roles and the policies, and then the last piece of it is that you need to configure your servers with the host certificate stanza, and of course you have to fill that particular certificate. How this looks on the server side, you request Vault to sign your host key. It's typically at this location, the SSH host RSA. If you have a different kind of encryption mechanism, of course, use the proper public key for that. And then you make sure that the SSHD configuration has the host certificate stanza. On the client side, query the Vault host, signing the CA endpoint. This is either an authorized or no authorized endpoint. The nice thing about having the no authorized endpoint is if it's actually exposed on the internet, anybody who's able to connect to these things can get that public key down. And then the client adds the cert to the known host file. Okay, now a word from our sponsor. Do you need a highly scalable yet simple way to schedule your applications? Do you have heterogeneous workloads that are not all containerized? And do you like or even love HashiCorp software? Then you should consider HashiCorp Nomad. Visit nomadproject.io for further information. And now back to our webinar. All right. Quick little prayer to the demo gods and goddesses out there. Please be kind to this demo and make it relevant for our end users. Okay, first off, we're going to start off with a PKI demo, and we're actually going to leverage the newly open source GUI. For those of you who have been tracking Vault closely, know that version 0.10.0 released open source GUI. It's quite nice and very nice that we moved this out of the enterprise area. And then we'll show what a renewal process looks like using console template. If you're not familiar with console template or haven't really used console too much, I highly encourage you to check that out. It's a very useful way to fill out configuration files in a very quick and automated way. All right, so with that, let's get over to our demo. Okay, great. So the very first thing that we're going to do is we're going to create the CA, and we're going to do this by enabling the secret engine type of PKI. We're going to give it a path called webinar-ca root. We're going to take the options down here, and we're going to extend this thing out here to be 3650 days. All right, enable that secret engine. Perfect. We're going to come over to certificates, do a configure. We're going to configure the CA. And we want this to be a root type CA with an internal certificate. If you have an existing CA that you want to import into the system, you can upload the PEM bundle. We are not going to do that. Common name is webinar CA root. You can see that I've actually practiced this before. And with the CA certificate, you have a full set of options that you can put inside of here, such as subject alternative names, IP names. We want to change the time to live, default time to live on this to 3650 as well for days. We want the PEM certificate. We're going to bump up the certificate bits as well, 4096. And then there's some extra information down here. So if you're actually using these certificates and you want to expose them to the outside world, it's often very helpful to add this extra information inside of here because this is going to be internal for a demonstration. I'm just going to leave these alone for now. Okay. For those of you that are aware of how CAs work, CAs are self-signing. So if you just kind of notice the last little bits here on the certificate, you'll notice that they're both the same for the issuing CA and the certificate. And that's just an extra little check to make sure that we have a CA set up. Okay, that's great. So we're now going to add in an intermediate CI. The process is very similar to what we were doing before. We're going to call this webinar PKI-int-1. We're going to change these. Let's just say we're going to make this 365 days for this particular intermediate. We'll give it a normal time frame. This webinar is shorter than that, so hopefully we won't be here in a year talking about this still. And we're going to enable the ticket engine. One thing to be very leery of though, when you create this, make sure that your intermediate engines have a shorter TTL than your root CA, and make sure that they don't expire before your root CA. And the reason for this is that if the root CA expires before the intermediate CA does, then you're actually going to get the intermediate will expire as well. So be very cognizant of that if you're playing around with shorter TTLs. All right. Okay, great. So let's go to the certificates for this guy. We're going to configure another a CA for the intermediate. We're going to change this to the intermediate CA type. We're going to leave it as a internal type of certificate. Okay, and none of the rest of these options we're going to use. Actually, that's not true. We're going to change this to 4096, and that's that. Okay, now what you notice here is that the intermediate is going to generate a CSR, and then you can, actually, let's use the copy button. That works great. So then you can use a CSR if you have an external CA. This is the one that you would walk to your other CA or send via an electronic means. However, that's not what we're going to do. We're going to use the CA root that we have here. We're going to configure this. We're going to sign an intermediate certificate, paste in that CSR. Let's see, we want to make sure that we update this time to live to days. Permitted DNS domains, we'll leave that all alone. We'll do that later when we create our roles and our certificates. We're actually going to just leave these here to go. All right, I'm going to copy the certificate. I'm going to go back to my secret engines, which is my web PKI int. I'm going to configure this, and then I'm going to set the signed intermediate. And this is the signed CSR that we just got from our CA. That's great. And so at this point, if you need to get the certificate, you can pull this down from the GUI. You'll have a chance to do this later if you want to do it from command line, or if you want to do that here sometime later as well. Okay. Okay, now the next step is to create a role. Roles are used to determine what the capabilities are of people who are logged in as these particular roles. And so, let's see, let's create one for a particular set of things. What do we have? We've got webinar.hashicorp.com. We're also going to jump this up to 4096. And the TTL for these, wow, let's be really aggressive with this. Let's just set it for a 1 minute TTL. Okay, so again, some of the options that you have for the certificates that you're signing, allowing a host name, you know, be somewhat careful for that when you allow that, because anybody could create something with anything that they want. You have the same organizational issues that you have here. Key use is also quite important. If you want to use this thing for encryption and decryption only, then we've got key encipherment. You can use this for signing as well, and for doing like email signatures or file signatures. Let's see, domain handling. Let's allow subdomains and glob domains, and then let's only allow webinar.hashicorp.com. And so any of the hosts that we create will have to be inside of this domain. And let's see, what else do we have? Oh, underneath this is actually fairly important. If you're going to use something like console template to handle the certificates that you've created, you need to make sure that you generate a lease for that. And so make sure to generate leases for anything that you're going to use any kind of automated tools with. And of course, you have policy identifiers if you have a need to add certificate policies inside of there. The capabilities are included in here as well. All right, so we've got our role. And now that we have our role set up, you can actually go to generate the certificate. If I give it a name, 42.webinar.hashicorp.com or .com, I can take this TTL for the certificate, drop this thing down to 1 minute, and generate more certificate. Now, this probably isn't super helpful for you if you're using this in an automated fashion of having certificates with very short TTLs being put inside of a GUI, because you'll have to distribute those to your host outside and around. So this is just an example of what it's like to create those. Most likely you're going to use an automated way of doing that, and we'll be doing that here shortly. Okay, the next thing that we need is that we actually have to create some kind of a policy that allows a user with some kind of a token or another authentication method to access the data that's inside of here. So we're going to need to create an ACL policy that'll allow this to happen. Let's give it a name, webinar one issuer. I'm just going to copy and paste this from another terminal, so we're not waiting for me to type badly. Okay, we're going to create this policy. So let's talk about what this allows you to do. The endpoint webinar PK int1, that's the mount point that we have for intermediate domain or intermediate CA. And the issue endpoint is how you actually get the certificates. You need to be able to create or update on those endpoints in order to get that. And then we've created a path to the webinar CA route, the cert CA, which allows you to read in any kind of CA certificates that are there. This is extremely helpful if you actually want a full certificate chain. And then the ability for this particular user to renew their tokens and renew it on their own. So let's create that policy. Outstanding. Okay, cool. Now let's get to a little bit more of an automated way of doing this. Okay. All right, so let's do a demo of the PKI. Big thanks to Jeff Mitchell, our esteemed engineer on the Vault side of things. Oops, look at that. I made a mistake. I made it oops. So demo equals true. I'll make sure we do that. Sorry, I was invoking Jeff and then I screwed this up. Okay, let's do this. So we're gonna do the demo of the PKI. Oh, look at that. I'm missing my demo just went crazy. Okay, so what's happening here in the background is we're generating these certificates. Let me scroll up right here. Wow, that's a lot of information. Okay, so we're going through setting some policies, generating the certificates, and then running the actual console template over here. Okay, outstanding. Okay, cool. So this other side over here looks like my prayer to the demo gods didn't work so well. Okay, so what was actually happening on the other side is really just a bit of a setup for console template, and that should have gone a little bit slower. But basically, what I've done is I've generated the certificate, and then I'm using console template to read in some templates that I have, and I'll show you what those look like here shortly. But those templates are basically taking information. They're looking at the issue endpoint, and then issuing certificates for that particular endpoint. And one thing that you'll notice here on the right-hand side is that the certificate fingerprints are rolling over a period of time. What console template does is it actually reads that lease that we were talking about earlier, and it has an understanding about when that certificate is actually going to expire. Before the certificate expires, it reads the information in and it generates the template. And so basically what this is doing is this is reading this into a file, and I'm using an OpenSSL process that's listed up above here just so you can see this. This is doing a verify against the CA chain. And then just shortly afterwards, it's doing the fingerprint. And so we'll see what that looks like when it rolls through here. Demo equals true. And so what does it look like if I actually revoke this thing? So if I do a demo revoke, what this actually does is it's going to go through and revoke the token that I've created to log in and get these. Now, in the next window, What we should notice right away over a short period of time is that console template is going to start failing when it tries to renew the actual certificates. Okay, there we go. So we're now starting to see a failure from console template because the token that it's using to log in isn't allowed to log in anymore. So permissions denied. And this is the part where you have some kind of a break glass where maybe you know that you have a certificate violation within your domain. You can remove any of the credentials that have access to produce these certificates, and then whenever somebody goes to actually renew the certificate, that certificate renewal will fail. And this is the part where if you have short-lived TTLs, you don't necessarily have to use a certificate revocation list, because certificate revocation list will have to carry the length of any of these certificates for the length of time that the certificate would actually supposed to be alive. You can use this as a way of actually preventing the maintenance of those CRLs. And so what you look at over on the other side over here is the fact that now we have the certificate is expired, and no longer if you have applications that are talking to each other and that are actually enforcing the certificate expirations or any of the certificate information, they should stop communicating with each other instantly. Okay, so let's try this again. Nope, I'm still having a failure on this guy. That's okay. We're still going to go through and reissue this thing with the console template. Okay. And then what we should see again over on the right hand side is that these things will start to be okay again. And so right away, console template is able to log into Vault, and immediately it starts producing certificates that are okay. And let's just wait. Okay, good. And so it's renewed the certificate. We can see the fingerprint right here, and that certificate is changing. All right. Okay, so that's a brief introduction to the SSH-CA piece of this. I'm gonna go ahead and clear, oops, that's how you spell clear. All right, that's great. Okay, now onto the SSH-CA demo. This one has a little bit of a scenario here. The scenario is that you are a security consultant aboard a new space station called, codename, the Lifestar. The space station is under attack by rebel terrorists, and the leadership wants you to analyze the attack. However, your AI is offline due to the fact that your space station just annihilated the planet Alderaan the AI was created on, and it just up and quit due to an unknown licensing callback. There's another remote AI on Dantooine, but there's no time to fly its core to the Lifestar. You've been tasked with granting the AI remote access to the remote sensor units. Wise of the ways of the Force, you decide to use your newly installed Vault server to sign the AI's SSH keys with your Vault SSH-CA and allow it to connect to the sensors directly. Okay. Star Wars fan, that's right. Anybody know where my t-shirt comes from? Yeah, okay. Classic. All right, here we go. All right. Let's do this guy right here. Let's try this. Oops. Let's try to export the demo equals true this time. Okay, so let's demo the SSH-CA. Maybe we should do this on a bigger screen. That'll be nicer. Okay, I'm just disabling any of the secret engines in the event that they were already enabled. I've been practicing this. So right away, the first thing we're going to do is just look at what the SSH configuration looks like. So it's important to notice that we have both the host certificate set up and the trusted user CA key set up. I picked these particular names. You can use any names that you want. Okay, we're going to enable the SSH secret backend. And I'm going to run through this a few different times. And after I get done with it, I'm going to explain to you exactly why I'm doing this. And so the next piece of it is I want to generate the CA for that particular mount point that I've created. And right away, we should get some information back about this key. There we go. That's what my CA key looks like. I'm going to look at my roles that I've created for my JSON file. of particular interest down here, if you want the TTL, that's basically saying that any of my admin users are able to log into the system for up to 24 hours using that certificate. Here's the user we're using. That's default user. That's just basically because we've created these things using Terraform, and I'm just using the default user for now. Of course, you can use any that you want, and allowed users as well. The default extensions part, if you actually want to log into your systems, make sure to put permit PTY in here. And then agent forwarding, port forwarding, I use those quite a bit, but you don't necessarily have to use those. In highly secure environments, it may be more desirable that you don't actually allow agent forwarding to make sure that you can sort of reduce the blast damage of what everybody's able to do here. I'm going to write the role into Vault, and then a look at what the policy looks like. This is very similar to the policy that I created for the PKI engine. Very similar. This is allowing you to sign for that particular user, and then of course to read the CA information that's there. I'm going to write that policy out there, and then I'm going to create a token that's actually able to access this policy. So this is the piece that allows you to actually log into the system. Okay, now I'm going to do a user level one. I'm just going to kind of blaze through these really quick, but the whole reason that I've split these out into separate endpoints is because you may have people who have a very short-term need to communicate with these systems, and then you may have people who have a much longer-term need. What we're actually going to do is we're going to use this temporary endpoint right here, but I just wanted to show you that the SSH backend, because you can mount several of them at a time for the same type of capabilities, it just allows you to sort of tier the information in a customized way. And in this particular sense, we're just giving a TTL 10 minutes for this particular user to be able to log in with their certificate. Okay, we're going to sign these things, write the policies, and then create that token. Now, if you look inside the SSH CA keys, it's written in these bottom three. Sorry, it looks like I left some in there from last night when I was practicing, but here's this SSH CA keys that were just created recently. Okay, now onto the host signing piece of it. That's to prevent those messages popping up that you're connected to an untrusted host. We're going to actually do the same thing. The process is very, very similar. Look at that, I got the full output back. That's great. Okay, I'm going to tune the max lease for this for kind of a long period on here. And then I'm going to write this host role into the system. Again, this is the capabilities of what that CA certificate is allowed to do. And let's see, let's write this guy. That's my public key from my particular system itself. So this is my SSH RSA host key. Again, if you have a different type of encryption, then use that instead. And then I'm going to make this a little less easy to get a hold of. And let's take a look at our secrets. So, like I was saying before, right now we have the SSH CA stuff that we just created right now. And then if you notice from before, we have the webinar CA root and the PKI int that we were putting in there beforehand. Okay, I'm going to create a token that has access to all of those things. And there we go. I'm at the end of the server part of this. Let's see, I don't think I need both of these. Demo. Oops. Let's look at all of them. Demo sign, there we go. That's what we want to do. Let's do the signing key. Now, I think I might be missing something. Hold on just a second. I'm going to do this out of band for security reasons. Webinar Vault PKI. Actually, I'm going to bring this out of here. Oops, sorry. I don't have the right token installed on the system yet. I know. It's going to make this fit this demo very short. Oops. Okay, let's try that. Okay, sorry about the delay. All right, let's do the demo. Oh. Let's do key signing, sign key login. Okay, here's my public key that I just created, and the SSH known host basically went out and grabbed a cert here, change the permissions for this thing, and then I'm actually going to try to SSH to this other end. Oh, I know what I did wrong here. Sorry, guys. Let's do a demo of SSHCA instead. Oh, geez. Okay, great. So I'm going to look for trusted CA keys inside my SSH config. Oh, geez, I grabbed the wrong one. Sorry, guys. Sign key. I was actually on the wrong one. I was at the right place. Okay, let's get back to where we're at over here. Okay, good. Changing the permissions. So basically what this is showing you is that I'm trying to log in using my certificate right here. I'm using, of course, my my private key that was set up before. My connections to the other systems were using another key. I'm going to look at the payload. This is actually my current public key. And then I'm going to look at the endpoint for Vault, which is at this location right here. I'm going to sign the certificate with my pub key, and then I'm going to attempt to log into that server. So the important piece here is that if we look above, we actually weren't able to log into the server. Now what I've done is I've signed my key. I've gotten a host key signing, and as well as that I've signed my particular SSH certificate, and then afterwards I've attempted to do the same login. And one of the things that you'll notice is that I didn't actually get the pop-up on my screen about the host being unknown. And so here we are, and we've logged onto the system. I'm able to see all the stuff on this Bastion host, and there we are. Okay, that's great. So let's see. Did we do everything we're supposed to do? Yeah, absolutely. So that's the end of the demo portion of this. Thank you, and may the 4th be with you always. We have time for some questions. I'll hand it back to Amanda and let her fire on my way. Thank you.
Hey, Jake. Okay, great. Thank you. Great demo. So let's see. First question. So someone's asking, how well does Vault scale with lots of CAs mounted in PKI backends?
I mean, Vault is extremely scalable, and depending, of course, on your needs, we can scale these out to multiple data centers. We can do DR recovery. We can do lots of replication. So a lot of it comes down to what your actual needs are. So I don't know what the physical limits are of it in terms of the CAs, but it'd be interesting. We'll have to take a look at what the limits on that are. We have very, very rarely run into anybody who has a performance problem unless they're pushing massive amounts of requests towards Vault, and most people haven't come anywhere close to that limit yet.
Great. Okay, and then kind of related to that, someone mentioned they got a little confused of how to organize the CA. So they're saying they're asking if you could go over again the multiple CA intermediate structure again. They got a little confused on the organization.
Right. So typically speaking, when your applications are verifying that they can talk to each other, the thing that they look at is the entire CA chain. Okay, so if I have, say, an HR app combined with maybe like an IT app, and I don't necessarily want them to see information between the two of them, then I can create multiple intermediates and sign them with different intermediates. So maybe this intermediate on the left side is sort of the HR chain, and then this on the other side is the IT chain. And so the idea is that when you're issuing your certificates from the intermediate level and then creating the chain back to the master CA. And so because those things have different, they have different paths, they're technically in different domains of the certificate domains. And of course, a lot, depending on how you're enforcing your certificates from your application side of things, this can help isolate things. I'm not sure if that made anything any clearer.
Hopefully, we might hear from, if not, we can go ahead to feel free to ping us again and we can follow up with Jake. But okay, so Jake, next question. So someone's wondering, they're asking, how does HashiCorp certificate management solution stack up against traditional certificate management, such as Vinafi?
Okay, well, where HashiCorp CA really comes into the SSH PKI thing is probably along the lines of something that you've done if you were scripting like OpenSSL or using a tool like CFSSL, for instance. If you need to have actual trusted CA signed certs, this isn't necessarily the best place for that, unless of course you actually have a root signing certificate that you want to put inside a vault. Typically we'd say if you have a root signing certificate, it's not the best place to put inside a vault. Most people will keep those air gapped. So again, it depends, like if you're using Let's Encrypt or you're actually doing something, say, through like Namecheap or something along those lines to have your trusted CA or trusted certificates, I would continue using those processes because those are for more like long-term type of certificates. This is really for short-term certificates or internal type things. What's popular is like MTLS, or if you're doing code signing for any of your code inside of there.
Okay, great. And then someone's asking, is there any way to restrict the usage of issued TLS certificates in Vault? For instance, code signing, auth, encryption, etc.
Yeah, absolutely. Those extensions are inside of there. Let me see. Let's look inside of the PKI. Oops, sorry. Let's just come back and create this thing. Oh, geez, I've got a bunch of these things inside of here. Oh, actually, let's create a new role. So if I come into a create role, so key usage, that's what this block is right here. So right now we're using these things for key encipherment. But yeah, if you need to change any of the capabilities to certificate, we have the full capabilities that are included inside of the Go library. This is based off of the Go stuff. So any of the capabilities that you find inside of the Go library for SSH certificates for PKI, you have those exact same capabilities within Vault.
Okay, great. And then next question, someone's asking, can an SSH server be configured to accept an ephemeral SSH key only once rather than have its efficacy be determined by expiration only?
Oh, wait, could you say that again? Sorry.
Sorry. So can an SSH server be configured to accept an ephemeral SSH key only once rather than have its efficacy be determined by expiration only? So I guess
yeah, absolutely.
Expiration date.
Yeah, there is some key usage things in there. Let's see. You can actually set it down to the amount of usages that you have. So you can do time-based, or you can actually set the amount of usages that you have. So if you just want somebody to allow it to log in once, then you absolutely can do that. Vault also has an SSH one-time password functionality as well, so I highly encourage you to check out the docs on there. But yes, that capability exists.
Okay. Next question: is it better to bootstrap Nomad console Vault clusters without TLS, and then create the root and intermediate CA in Vault, and then enable TLS?
It depends. I think it really depends on the type of pattern that you want to use. Terraform has a way of producing TLS certificates, and one method that I've actually used in the past is that I've created a Vault dev server just to stand it up and create a set of TLS certificates. I dump those out into file format, and then after that, stand up the actual Vault server. So that's a pattern that you can actually use as well. So I'd encourage you to check out. Vault has Terraform has a PKI provider as well. So check that out, and then maybe look at the pattern of using a dev server, a Vault dev server, to just basically dump out a set of CA and intermediate certificates for use for your applications, and then you can lock those down using those.
Okay, great. Next thing, someone's wondering what certificates need to be propagated to hosts in order to trust certificates generated by Vault. Do you need to import the root and or intermediate certificates into the trust stores?
Yeah, if you're talking about Java trust stores, you'll definitely want to import the entire CA chain into the trust store. So yeah, I mean, that's basically it. So make sure that you have the entire chain imported into there.
Okay, great. And Jake, so how would you use a private key from an HSM with Vault?
Ooh, I think that really depends on the situation in which you're trying to do. I know we do some auto unsealing and whatnot with Vault. I'm not necessarily sure about the workflow of signing, say, like certificates or anything like that. It'd have to be something I get back to you with.
And then are ECDSA supported?
Yes, absolutely.
And let's see, do you need HA for Vault on AWS?
Well, I think that depends on your organization. If you have an organization that needs HA, then absolutely. If you don't, if you're using open source and you can get away with one server, not necessarily. Now, take into mind that Vault is sort of an HA setup anyways, right? So if you have multiple Vault servers, even in the open source product, then yeah, it's sort of HA on its own. If you have a more stringent guideline of like disaster recovery or something along those lines, you'll need to have Vault Enterprise, and we can help you with that if it's something you're interested in.
Great. Okay, thanks, Jake. And next question, this is a good one. A lot of people use Kubernetes. So someone's asking, can you use Vault with Kubernetes?
Oh, yes, absolutely. This is something that we have some reasonable patterns on. I'm not sure if we have a webinar anywhere in the near future, but most of our SEs, or a good number of them, have been working on Vault Kubernetes integrations, and there's a ton of language and a ton of capabilities out there in the world about how to do this. Yes. I think Kelsey Hightower just did some posts recently, so you can check those out as well.
And that might be like a good note actually to point out, Jake, how each of our tools, how we build them, the way that they actually don't need to depend on each other. You want to maybe touch on that, of how they can kind of.
Yeah, absolutely. I mean, HashiCorp tools are designed to be very modular in nature. And so if you for instance, you're using Kubernetes for your scheduling layer, but you want to use Vault or even Terraform to help launch those things, absolutely use those tools to do that. We actually had a very interesting demo that somebody did recently where they ran Kubernetes on top of Nomad, which is sort of like, the inception version of it. Maybe there's some Meso stuff underneath there, but absolutely, yeah, use our tools as plugins, anything. I've actually seen patterns where people use console inside of Kubernetes because they like the service registration. That comes with some benefits and some downfalls as well. It's a little bit more difficult to implement, but we've seen people be successful with patterns like that as well. So absolutely, use the tools off the shelf in any place that they make sense within your environment.
Great, thanks, Jake. Okay, so the next question, someone's asking if Vault can generate certificates and keys on its own without using OpenSSL commands.
Oh yeah, it's not using OpenSSL commands. The OpenSSL commands that I was using was just for the verification of the certificates actually after I'd actually dumped them out using console template. But yeah, the entire thing is done inside of Vault itself. And so the PKI side of it, I showed the setup using the GUI, but there's the API and the command line interface is it's very rich, and you can do all that inside of there. So there's no OpenSSL. It's actually using Go libraries to do the certificate creation on the back end. So there's no OpenSSL involved in there.
Great. Okay, thanks for the clarification. Jake, I think this came up towards the beginning part of your demo. Someone's wondering where you buy your shirts.
Oh, yeah, so I got this, I think this one I got from Threadless, I'm pretty sure. Yeah, I'm pretty sure this is a Threadless tee, so check that out.
Okay, thanks. Okay, next question. Should you create separate certificate roles for Nomad server? So Nomad client, console server, console client, etc. Or is the new server flag and client flag sufficient?
Ooh, I'm not necessarily sure about that. I'd have to get back with you on there. I'm guessing that the client server flag is a good, but I'd be guessing at it. So that's something I have to answer. So if we have their email, we'll try to get back to you on that.
We can email them.
Okay,
Okay,
cool.
can Vault store Java keys?
Sorry, what? I'm sorry.
Can Vault store Java key stores?
Oh, yeah, I mean, it probably could. Well, actually, that's not true because Java key stores are usually quite large, and and I think some of this depends on the backend that you're using. But typically, what we tell people is not to store very large type of files inside of Vault. It's not necessarily designed for that type of thing. So it can help you generate those certificates that you would pull into the key stores or into your trust store. But key stores and trust stores also have ways of locking down through passwords or through other authentication mechanisms, and so they're kind of like their own entities. And so I wouldn't suggest people put large binaries inside of Vault. You probably find that depending on your backend, you couldn't do that anyways.
Okay, great. So next question, we have a few more. I know we're getting close on time. Can you do your CSR offline, let's say with Terraform, and then use Vault CLI API to import it?
Yeah, absolutely, you can. And that's what I was talking about in the beginning. If you have an existing CSR process, so maybe your applications automatically generate their CSRs, you can sign a CSR inside of Vault, given, of course, that you have the intermediate that's already set up for that. So yes, absolutely, you can.
Okay, great. And then someone's asking, are the encryption algorithms FIPS certified?
Oh, my guess is yes. I would say yes, but that's something I have to get back with you. I'm sure that all of our most, if not all of our vault functions are certified as it is, but it's something I think we could probably find inside the documentation for Vault, but I'm pretty sure that the answer is yes.
Okay, yeah, I think we hit that last year maybe, but we can clarify an email.
Yeah.
Um, and then, so just two more questions. Someone's asking, does Vault have any integration with OpenStack?
Ooh, well, I don't know that there's any sort of known integration endpoints like that, but OpenStack has the ability to create API calls to Vault, and then yes, absolutely. There may be some open source projects out there to do just that. I'm just not aware of what they are, but yeah, I mean, Vault has a very rich API for calling things directly within the API through, say curl mechanisms or directly with web requests. So you can always interact with it that way.
Okay, great, thank you. And then final question, Jake. Someone's asking what is good TTL for client certificates issued for two Nomad jobs? Should it be minutes, hours, days?
Oh, wait, so could you say, I didn't hear the first part of it.
They said, what is a good TTL for client
Hmm.
certificates to Nomad jobs? And then I think they're saying for instance, minutes, hours, days.
Right. So again, I think this really depends on your style of workflow. If you have a way of sort of renegotiating those certificates, then you could probably set it at any kind of TTL that you want. However, again, it's really comes down to the needs of your organization and what you feel you're comfortable with in terms of any kind of blast damage that could happen from a leak certificate. My guess is that I would set it for something that's maybe a little bit longer, like a day or so. But again, based off from the like the council template pattern of being able to renew those certificates, if you have something like that in place that's able to do that, you can set it for any length that you want. But yeah, I mean, I would start off with maybe like a day at first, and if you want to experiment bringing it down, then of course you could do that.
Great. Okay, thank you, Jake, for the clarification. So those were lots of great questions from the audience. Thank you, everyone, for your participation. I hope you enjoyed today's webinar and you're able to learn a bit more about streamlining your certificate management with Vault. Jake, thank you for your time today, and thank you, everyone, for joining.
Yeah.
Finally,
Hey, Amanda. Just a heads up, could you just leave this running for a second? I want to run through the questions and stuff like that because I didn't get to see them earlier. So I'll be online for just a second, but that's just to see who actually run the thing. So it looks like we have Alan Comic was the person who won the fighter jet one, and let's see, I don't know anything. Yeah. Okay. So anyways, I just wanted to check out who had that. Okay. Thanks.
question at the beginning, Jake, on the plane.
Yeah.
What was the correct answer?
Yeah. So the correct answer is an F-15 Eagle, and Alan Comic was the first one that came in with it, and it doesn't look like everybody got it. It was actually stationed at Tyndall Air Force Base. This was what the TI was for. So thanks.
Yes, thank you. Sorry.
Yeah, it's okay. It's okay.
Alan, we'll reach out to you. Thanks for getting that correct. Okay, and then finally, as I mentioned at the beginning of the webinar, this was recorded, and we will make the recording available on our website after processing. I'll also send an email to everyone who registered with the recording link, along with info on our next webinar. You can keep your eyes out on Twitter. I'll post the recording link usually a little later today. So thank you, everyone, for joining, and have a great day. Goodbye.